We began chapter 7. We're going to continue that today. And today we're going to talk about similar polygons, and we're going to use some of the ideas that we learned yesterday when we were solving proportions to find various sides of our polygons. First thing we need to do is identify what similar polygons are. Two polygons are called similar if all the angles are congruent. I don't know why that's not showing up, but we'll write it down. Congruent. And all the sides are proportional, meaning the sides are in the same ratios. A statement of similarity tells us what sides correspond to which and which angles correspond to the other angles. Just like when we were writing congruent statements for triangles, we could tell what angles were congruent and what sides were congruent. This is going to tell us what angles are congruent and which sides are proportional. So in this example, it says the sides are, given that the sides are proportional, and then this symbol right here, that means similar. So A, B, C, D is similar to H, G, F, E. Notice that angle A is congruent to angle H, and it's marked that way, here and here. Angle B is congruent to angle G, angle C is congruent to angle F, and angle D is congruent to angle E. Again, the order does really matter. Now, we also know what sides are proportional. Just from our similarity statement, I'm going to erase this just a second. We can tell that side AB is proportional to HG, just because of the way the letters line up. The similarity statement tells us everything that we need to know. BC is proportional to HG. GF. And CD is proportional to FE. And AD is proportional to HE. All of these ratios are equal. Take a few minutes to write this example down on your paper if you need to. When you're done, press play and I will continue. So I had this right on the other side, on the other page. We are just lining up our angles. The symbol that's in the middle here just means similar. And I know that all the proportional sides line up as well. So here's an example. I'm given a similarity statement with two pentagons, and I want to match the congruent angles. It's really nice that the picture pretty much, it looks like angle A is congruent to angle J, but what is really important is that I look at the similarity statement. Again, tells me everything I need to know. Angle A, since it's listed first, is congruent to angle J. So I'm going to move this guy down here. I'm lining up the congruent angles. Angle B here is congruent to angle K, and so on. Angle C is congruent to angle L. Angle D is congruent to angle M. Angle E is congruent to angle M. And again, if you need a few minutes to write that down, press pause, and then again, press play when you are ready to continue. Now, I have another figure, and what's nice about similar figures is, well, I guess we're not there yet. Right now, I just am saying whether or not the triangles are similar. The way I'm going to know is if all the sides are congruent and all the angles are congruent and all the sides are proportional. I'm going to make this a little bit larger so I can see it. So if I look at my angles, it's clear to me that they're congruent. They're marked that way. Angle Z is congruent to angle Q. Angle Y is congruent to angle P. Angle X is congruent to angle R. Now, I now have to look to tell if the sides are proportional. I'm going to compare small side to small side, medium side to medium side, and large side to large side. So, first, I'm going to compare 4 to 6, PQ to YZ. And I'm going to see if that matches up with my other sides. The next side, larger, is side PR, and that is 6 compared with 9. And then I'm going to compare the next side. 10 compares with 15. Remember, small to small, medium to medium, and large to large. Don't go based upon how it looks, go upon based how it's labeled. So now what I need to do is I need to tell whether these ratios are all equal. So I'm going to simplify all of them. And this one becomes 2 over 3. 6 over 9 becomes 2 over 3. And 10 over 15, divide the top by 5 and the bottom by 5, 2 over 3. So sure enough, all of those sides are in the same ratio, meaning they are proportional, and all my angles are congruent, and therefore the triangles are similar. I need to write a similarity statement, and it's important that I write it in the correct order. I'm going to line up my angles. Triangle ZXY is similar to triangle QRP. And the answer, again, is yes. A scale factor is, if two polygons are similar, the scale factor is the ratio of the lengths of the two corresponding sides. So, as our last example showed us, here I'll split the screen here. Our scale factor in our last example would have been 2/3. It's the ratio of two corresponding sides in similar polygons. Here's an example. I have a rectangular patio around a pool, and it's similar to the pool, as shown. I want to calculate the scale factor of the patio to the pool, and I want to find the ratio of the perimeters. What's really important here is you've got to read it carefully. Whatever number I list first is going to be from the patio, and the second one is the pool. So if I were writing this as a fraction, I would put the value from the patio over the value from the pool. Okay? So again, the pool is similar to the patio. I want to calculate the scale factor of the patio to the pool, and I want to find the ratio of the perimeters. Well, the patio width is 24, and the pool is 16, and then we would reduce that. 8 goes into each of these, so I end up with 3 to 2. So the scale factor is 3 to 2. And then I want to calculate the perimeters and then find the scale of the perimeter, the scale factor of the perimeter, the ratio of the perimeters, the perimeter of the patio to the perimeter of the pool. I'd like you to pause, and I'd like you to find the ratio, again, of the perimeters. Press play when you're ready to see the answer. Well, here we go. I've got a scale factor from the patio to the pool. Again, we said that it was, I don't really like this decimal here. This is 3 to 2. And when I found the perimeters of the patio and the perimeter of the pool, I found that it was 144 to 96. and that is 3 to 2. And at this point, it should be pretty obvious what you notice. The scale factor is equal to the ratio of the perimeters. Okay, and that leads to a theorem. If two polygons are similar, then the ratio of their perimeters is equal to the ratios of the scale factor. The rate is equal to the scale factor. In other words, the ratio of their corresponding side lengths. So we're going to look at this figure. I know that they're similar. I have two quadrilaterals, and it tells me what order that my angles are congruent. And I have the perimeter in my numerator of polygon KLMN and the perimeter of my denominator of the polygon PQRS. That ratio is equal to the ratios of the corresponding sides. So this is equal to KL over PQ, LM over QR, MN over RS, and KN over PS. Again, feel free to pause at any time. You need more time to write down. When you're ready to go on, press play. Now, we can use the fact that polygons are similar to solve for missing values. So it's a little hard to read these numbers, so I'm going to write them in a little bit better. The top one there is 10. This is 15. This is a variable I don't know. And then the top one over here, PQ, is 6. So I'm told that these polygons are similar, so I'm going to write a proportion and solve for z. So KL is to QP as LM is to PS. And again, I get that just by looking at my similarity statement. So 10 is to 6 as 15 is to z. And now I can cross multiply and solve, or in this case, I think I'm going to just simplify the 10 over 6 so that it is 5 over 3, and it makes my arithmetic a little bit easier. So then at this point, we're going to cross multiply. That is 5z equals 45, and then divide both sides by 5, and I find that z is equal to 9. So if I know the polygons are similar, I'm able to solve for missing sides, so long as I have one set of corresponding sides that I know so that I can find my scale factor. All right, this is the homework. It's going to be posted on Schoology along with the answers, and I will see you tomorrow.